Hi, everyone. Kind of a weird day today that we're not meeting in class. So I am creating our lecture online. I will be posting this to D2L. Of course, you will be listening to this before you even know that. So I don't know why I said that. But anyway, hopefully we'll be back in the classroom on Wednesday, and we will do some more of these on Wednesday. I wanted to make sure to at least go through one. It might take a while because I do have all the little pieces that I have to remind you of. We went through a lot of different ideas on the day before break or right before break. And we'll be using those pieces here to help us. So the first thing I'm going to do is we're going to try to find all of the zeros for this graph. And then after we have all of our pieces, we're going to talk about end behavior, how things behave near the zeros, and all of that kind of stuff as well. I also am going to do another example that is not in our notes, that is going to be already in factored form. I thought that might be a nice way to also kind of show you some of the pieces of how we can put all those things together. So this one, first of all, we're going to graph a function is we want to find all of our zeros, talk about the end behavior, do some test points, and I'll explain what all these things are as we go through this. So I want to first of all remind us, the first thing I do when I'm trying to find my zeros is I list all the possible rational zeros. So our possible rational zeros, if you can remember from the notes, they are of the form P over Q, where P is going to be a factor of our constant term, and Q is a factor of our leading coefficient. So the factors of 1, first of all, are only 1 and -1, and the factors that are 7 are 1, -1, 7, and -7. So our possible rational factors are both plus or minus 1 over 1 and plus or minus 1 over 7. So you can see the P coming from the 1 and the Q coming from that leading coefficient 7. And we're just going to randomly check to see if we can find some. And then we're going to do some synthetic division to reduce our fraction or our polynomial down. So I want to remind you, this is a third degree polynomial. Third degree. So it will have possibly 3 zeros. Think about how it would look if you factored these things. And it will have at most 2 extremes. So we talked about extremes being those humps and those valleys, or those wiggles and jiggles, as I called them before break, in between our zeros. So I'm going to just check some easy ones. And there's a couple of ways to do this. And we can simply just substitute them in and see if they turn out to be a 0, which is probably the easiest of the methods. So I'm just going to check the number 1. So I'm just going to check x equaling 1. Why I chose x equaling 1? Just a random shot in the dark. Okay. Before I do that, I kind of want to also go through, we talked about Descartes' rule of signs. So kind of getting off track here. Descartes' rule of signs. So if I look at my original function here, it started out positive, went negative, stayed negative, and then went positive. So I have one sign change and then another sign change. So this tells me there are 2 sign changes in P of x, which means by Descartes' rule of signs that we have 2 positive zeros, or remembering it can decrease that by a even number. So that means 2 or 0 real sign changes. I am also going to look at P of negative x, because that is the second part of Descartes' rule of signs. And if I look at negative x, that means I'm going to put a negative x in for my x. Okay, and now a negative x cubed is a negative x times a negative x times a negative x, which is negative x cubed. Here I have a negative x squared, which is negative x times negative x, which is still the negative from here, x squared. Here I have a negative and a negative gives me a positive. And now here I have that we are negative and then we change positive, so I have one sign change. In P of negative x. So that means we have one negative real zero. We're going to finish this off, real zeros. Okay, so I'm going to, like I said, I'm just going to randomly check. I should have checked a negative value, so I'm thinking our -1 or our -1/7 would have worked, but I already committed to that positive one. So I'm going to put 1 into my function and see what happens. So I'm putting that in. So I have, this gives me 7 minus 1 minus 7 plus 1, which is 0. So that means one of my zeros is the number 1. I am going to use now synthetic division to divide this out. So we're going to talk about synthetic division. And synthetic division is a quick way to divide something by a factor of linear factor. So since 1 is a 0, x equals 1 is a 0, that means it came from a factor that looked like x minus 1. So thinking, just moving the x, the 1 over to the other side. So thinking x minus 1 is equal to 0. There's my factor. I can divide this out of this function. I'm just copying it down here. But instead of doing long division, synthetic division is a shorthand way to do so. And the way we do it is we take that 0, that 1 that we had, and we're going to divide it into, and we just look at the coefficients. Zoom in a little bit here because it seems to be getting a glare. There we go. So my 7, my coefficient here is a -1, my coefficient is a -7, and here is also a +1. Okay, the way synthetic division works is we bring down this value. So we take our 7, we take our x value here and our 7, we multiply them together, and we put that multiplier here. So 1 times 7 is 7. We will add these guys together. So that gives me a 6. We're going to do it again. 1 times a 6 gives me 6. We add, giving me a -1. 1 times -1 is -1. And this gives me a 0. This last number will be our remainder. And what that gives us now is what was left. So this is my constant term, this is my x term, this is my x squared. So 7x squared plus 6x minus 1. What I have just done is I have rewritten 7x cubed minus x squared minus 7x plus 1 as x minus 1 times this piece here. And now I'm going to get my other zeros from that piece there, which is a quadratic. And we can use our techniques that we know, either factoring it, quadratic formula, or completing the square. I will try, I'm just gonna jump right into the quadratic formula because that 7 is a little messy and I don't want to deal with that today. So I'm going to use my quadratic formula. So that's my negative b, which is a -6, plus or minus b squared, so 36 minus 4 times my a times my c all over 2a. So that's a -6 plus or minus. All right, that's going to be a 36 plus 28 all over 14. -6 plus or minus, that is, what is that? 64 all over 14. Square root of 64 is 8. So this one would have factored. So now putting my 2, doing those two values, I'd have a -6 plus 8 over 14, which is 2 over 14, which is 1/7. Notice that is one of those values that we said could be a possibility. The other one would be a -6 minus 8 all over 14, which is -14 over 14, which is a -1, which is also one of those possibilities. Notice also we have two positive real zeros, the 1/7 that we have here and the one that we had tried before, and our one negative real zero. So now I'm going to start putting this and graphing this function. So, all right. What we've also kind of done is we have factored this cubic. We have factored it into x minus 1, x minus 1/7, and x plus 1. And what I'm going to do here with this guy is I could have pulled out a 7 in here and then distributing it in. And this isn't completely clear. So I will show you how we could have done this problem a slightly different way. So we could have gotten something that looked like that. This piece is a little bit more difficult to see. But since my leading coefficient was a 7x cubed, I know that I have to have a 7 out front of all my x minus pieces. Okay, but that's a little bit more detailed than I wanted to get to in this example. However, let's graph this thing. We have our zeros. Okay, we have a 0 at -1. We have a 0 at 1/7, and we have a 0 at 1. I'm going to do a really, really rough sketch by getting a few more other points. One very easy value to get is your y-intercept. We have that our function, and I'm going to write it in terms of y equals 7x cubed minus 8x squared minus 7x plus 1. Our y-intercept is when x is equal to 0. So doing that, we get that y is 0 minus 0 minus 0 plus 1. So we get our y-intercept at 1. Okay, we did talk about this being a third degree. Third degree leading coefficient of 7, which is positive, and third degree is odd. So that means odd is gonna start in the basement and end up in the ceiling or up in the clouds. So it's gonna start down here and it's gonna end up going up. And it's gonna have some wiggles and jiggles in the middle. So I could do a few more other points. So I'm going to just randomly pick a point to this side of my -1. So I'm going to let x be -2. I'm going to randomly pick a number between -1 and 1/7. I already did that at 0. I also want to pick one between 1/7 and 1. So I'm going to choose 0.5. And then I'm also going to pick a value that is larger than 1. What this is going to allow me to do is put a few more points on my curve. Okay, so I'm going to go into my function. So 7 times -2 cubed minus -2 squared minus 7 times a -2 plus 1. So this is 2 times 2 times 2 is 8, -8. That's a -56. That's 4 minus 4 plus 14 plus 1. So that's going to give me -45. So at 2, I'm down at way down here somewhere at a -45. So it's going to drop really, really quickly and continue to go down as our function goes down. Then it's going to come up and go through this point. It's going to come and again hit my 0 here. I'm going to put in 0.5. So 7 times my 0.5 cubed minus my 0.5 squared minus 7 times my 0.5 and added to 1. And I'm going to drag out my calculator for this one. So 0.5 to the third times my 7 minus my 0.5 squared minus 7 times 0.5 plus 1. And I get a negative 1.875. So if there's 1, there's 2, there we go, somewhere in there. So it's going to come down. I don't know if that's where it turns or not, if it turned a little sooner. Does not really matter to me when I'm graphing these. But I'm also going to do x equal to 2. So 2 cubed minus 2 squared minus 7 times 2 plus 1. So 56 minus 8 minus 14 plus 1. Again, I'm going to use my calculator. And I get 35. So then it's going to kind of shoot up there as well. Okay. And again, we can check our answers very easily by just graphing this in Desmos. The thing that this allows us to do is to actually get that value in fraction form. We got that that was a 1/7. Desmos would give it to us in decimal form, but knowing some of the stuff we did, we could get that in fraction form. Okay, I do want to go back to that original equation because you probably didn't realize, I got to make sure I write it correctly, minus x squared minus 7x plus 1. What I should have done before I just jumped right in, and that's on me, is I should have looked at this a little bit closer and said, can I factor it? And I would have said, oh, my goodness. Yes, I can. This one can be factored using grouping, factor by grouping. So out of these first two, I can pull out an x squared. And that leaves me with a 7x minus 1. Out of these two, I could pull out a -1, which also gives me 7x minus 1. Now I have two terms. I can pull out my 7x minus 1, and I'm left with x squared minus 1, which I can then reduce to, or factor down further to, x plus 1 and x minus 1. And there we would have had it already in factored form, and we could have set each factor equal to 0. And we can solve them. And here would have been x equals -1, and here is x equals 1. So there again are those 3 zeros done in a much faster way than using synthetic division and things like I did in the first when I was first working through these. Okay, I am going to do one more, but I want to do one that is already in factored form. So we can kind of work and not worry about doing the P over Q thing. I will talk more about the P over Q idea in a couple more examples this week when we come back on Wednesday in class. So please make sure that you are ready to jump right in and do some work. So I'm going to just look at, and I'm going to put some exponents on these pieces so that we can kind of see what happens when we have things, zeros of multiplicity. And we talked very briefly about multiplicity when we were, before break, when we were kind of just going through very quickly all the little details that go into these problems. And there is a lot of information in these three sections. 3, 2, 3, 3, 3, 4, 3, 5. I guess that's 4 sections. Okay, there are 2 zeros. And we can find them by taking each of those factors. Let's just say that this is f of x. And setting them equal to 0. So x equals -2 and x equals 4. We would say that x equals -2 is a 0 of multiplicity 3. This is a 0 of multiplicity 2. Because we could have written this out, this x plus 2, 3 times. So it's multiplied 3 times, and this x minus 4 would have been multiplied in there 2 times, multiplicity 2. Okay. But when we have multiplicity, the curve behaves similarly to the piece that it is in. So this one has multiplicity 3. So it is going to behave near the 0 like an x cubed. And if you think about having x plus 2, that x cubed is being shifted 2 units to the left. So we'll see that little cubic piece being over to the left a little bit. And I will probably also pull in Desmos on this one just so we can look at it as well. And this is where I'll end my video for today. But this one has a 0 at -2 and a 0 at 4. 1, 2, 3, 4. Okay. This is, if I multiplied this guy all out, I multiplied all of these together. I multiplied these together, I'd get a quadratic, so squared term. This would pick up a third term, cubic, to the 4th degree, to the 5th degree. So this is a 5th degree polynomial. That will be our highest power. Also, we can see that when we add those exponents there. Our leading coefficient will be the multiples when we have all those x pieces. So our leading coefficient is equal to 1. So that's positive. So odd degree, positive leading coefficient. It's going to do like the last one did. Start in the basement, end up in the clouds. So start down here, do some wiggles and jiggles in the middle, end up in the clouds. 5th degree could have 4 maxes and mins, so high points and low points. However, when you see multiplicity, a lot of that is going to kind of combine together. So we won't quite see as many. Oh, excuse me. I am going to do some test points. So I'm going to pick a point, to this side of -2. So let's just check x equals -3. We'll notice it is going to be a large negative number. I am going to get my y-intercept here. So I'm going to put x equals 0. And then I'm also going to choose maybe x equals 5. And I'm going to put it into my function, which again was x plus 2 cubed and x minus 4 squared. So putting in -3, that's -3 plus 2 cubed and negative 3 minus 2 minus 4, sorry, squared. So negative 3 plus 2 is a negative 1. And here we're going to have a negative 7 squared. So this is a negative 1, and this is 14. So this is going to give me a negative 14. So this would be the point, negative 3, negative 14. And it's going to come down here. When I'm getting close to this curve, and I shouldn't have just drawn it the way I did, this is coming from a cubic. So a cubic kind of does this flattening out and going through. So it's not going to go straight through like a line. It's going to actually come up, curve, flatten a little bit, and continue through. So it's not going to go straight through. We're going to have a little bit of a curve going through there. I'm going to put 0 in so I can get my y-intercept. So I'll have that 2 cubed and that negative 4 squared, which is 8 times 16, which I need my calculator for, which is 128. Holy buckets. So it comes way up. And it might continue up a bit and come back down. I do not know without calculus, or I'm sure that using Desmos we'll be able to see it a little bit better, how high up it goes. Okay, and I'm also going to put in 5 because it's going to come back down and hit my 0. Now this 0 comes from a squared, so it's going to behave like a quadratic. So, and that being the vertex, so it's going to come down, touch, and it's going to go back up again. So I'm going to have this 5 plus 2 cubed and 5 minus 4 squared. So that's 7 cubed and 1 squared. And 7 cubed is 343. Wow. So it shoots way up really, really, really fast. Okay, but let's pull in Desmos here for a second. Oh, and I don't think I have that pulled up. Shoot. So give me a moment to get Desmos pulled up here. Don't have Desmos open on my computer, so give me 1 moment. Yes, now I feel like we're in class. Okay. All right, so Zoom. Oops. Nope, didn't want that. I wanted that opened. Where's my, there we are. Here we go. And Zoom meeting. All right, we are going to go to screens and there we go. Okay, so in here, I will type the function that we had, and I'll do y equals. And we had x plus 2, and that was squared. And then we went right into x minus 4, and that was to the second power. And I guess this was cubed, not squared. Oops. There we go. All right, so you can see, first of all, near that 2, how that little flattening out, like a little cubic sitting there. This happens to be a very, very steep quadratic, very skinny quadratic, because it is being stretched as well. It's being stretched by this cubed part up front. So that's the part that's doing the stretching for us. And I suppose if we were to, I mean, it's going to take us a while to get up there. Yeah, I can't even get it up there. Our y-intercept was way up at 128. It would take me a while to zoom up there. But you can see the flattening, the cubic kind of idea here. And we can see kind of a very weak looking quadratic-ish thing going on at 4. So that's kind of what happens when you see multiplicity. If I change this to just a 1, okay, we can see it maybe a little bit better. So we can see more of a cubic, not a cubic, a quadratic going on there instead. If I had changed this to a 5, you can see more of a flattening. So a fifth degree will flatten even more than a cubic does. So we get that more of a flattening piece going on. And if I change this to a 4, you can see it flattening even more. So hopefully this gives you a rough idea. Hopefully you guys watch this video. Hopefully we will be back in the classroom on Wednesday. I'm sure we will be. And we can continue and do some more together. I am going to drag you guys along with me as we dive into finding the zeros, graphing these functions, painstakingly graph them, practicing synthetic division and maybe even a long division as we talk about slant asymptotes and things like that. That will be more when we hit 3.6 next week. This week, we're just going to be doing 3, 2, 3, 4, and 5 all together. And then next week, we'll do 3.6. Our exam is shortly after that. So just kind of watch the schedule. We do go through this kind of slowly, but there's a lot of stuff to just to devour and get through. Hopefully you guys are enjoying enjoyed your spring break. I look forward to hearing your stories when we come back. Until then, I will see you later.